Okay, let's revisit this problem one more time, and this time we're going to use method of joints. So let's say we feel uncomfortable with method of sections and we still have to find this one. Now we have to use method of joints. Of course, we always start out by looking for our reaction forces at A and at N, and it's because of symmetry again. We know that they should be 1 kilonewton each. Otherwise, we would probably sum our moments at N, solve for A, or the other way around, and solve for our NY, and work through the problem. So let's look at this. If we're at this point and we want to get to this one, we probably will start out at A, at joint A. And if we look at joint A, we have two unknowns there, so that will work out pretty well. We'll start out at joint A first. Okay, so I've drawn the joint A. Once I cut that out, I've drawn joint A, free body diagram. So let's look at this and solve for our members AC and AB. All right, so the first thing we can do is we can look at this and sum forces in the Y direction is probably the most convenient because then we can solve directly for AC. With that in mind, we have a positive 1 kilonewton going up plus AC times 1 over the square root of 2. This will yield AC equals a negative 1.414 kilonewtons. Okay, then the next step is to sum forces in the X direction. And for that, we have AB plus AC. I'm going to change that right away and put plus a negative 1.414 times 1 over the square root of 2. We can then solve for AB, and this will equal just 1 kilonewton. Realize that this is in tension, the other one is in compression because it came out negative. The next step is to look at the next joint, and if we look at this, we now know, if we highlight on here a little bit what we know this particular member and this member here. Now if we look at joint C, we then have two unknowns there. So let's take a look at joint C. Okay, so now we have joint C. We know this one force going down that we saw before was a negative 1.414. I again always draw them in tension. It helps us understand that if it's negative, that is in compression. We just need to be very careful with this method with our positive and negative signs. So if I look at this, I can easily solve for some of the forces in the X direction or Y direction. It doesn't really matter in this case. So I'm going to sum forces in the X direction. They should equal 0. If I do that, I have a negative times a negative 1.414 times our 1 over the square root of 2 plus CE. Okay, this will give us a value for CE. CE will equal negative 1 kilonewton. Okay, then we sum forces in the Y direction. So again, this is in compression. If I sum forces in the Y direction, I have a minus CB minus a minus 1.414 times 1 over the square root of 2. I can solve for CB. CB will then equal 1 kilonewton. Okay. So if we look at this, I've now solved for the forces in this member and this member. And it's just a matter of continuing this process on all the way up until we can solve for this member here. So I'd have to look maybe at joint B to be able to get this one. Then I can then get up to E. I still can't do. I've got too many. I need to do D. I can get those and then continue on. So it's a more laborious type problem when you want to solve for something in the middle. Like I said, the one on the exam itself will not be as large of a truss, so it will give you the option to do either method. If you have any questions, let me know.